Exercise 1, SolidWorks 2025. In this exercise, we're going to take a look at the functionality, the foundational functionality inside SolidWorks, and also we're going to look at the options that you can set up for this. All right, so to begin with, what you see up on the screen, that's what we're going to build today. And it essentially is there's going to be some sketches involved. You see this 3x5 block and 0.5 deep. And then also this little step. We're going to put some fillets in. Fillets are basically radiuses, as you can see here, there and there, nice and rounded. And then we're going to put in some chamfers. That's these blue areas here, which is just a straight angle, 0.125. And also we're going to go ahead and put in this hole. And so we'll learn how to cut material with that, and you can see the parameters there. Now also on the back side, we're going to learn how to shell it as well. So there's a number of things that we're going to cover in this, as well as some of the colors and settings that you see. To begin with, let's start off with the new part file. So what you could do, you could either tack this in. By default, it's not, but see this little arrow right next to where it says SolidWorks? If you hover over that, you get pull downs. Go ahead and hit the little thumbtack. And that way, I like to use pull downs. It's sometimes easier than calling up different things as far as icons. All right, so now we're going to go to new up here. And you'll see by default, you have part, assembly, and drawing. Now, depending upon how your system was installed, we're going to use inches today. Metric is superior, in my opinion, but since I'm here in the United States, that's what we're going to use. All right, and so you can see here you have part. You also have advanced, and these are templates that you may or may not have. We're going to stick with novice. I do have a video on templates. You could go ahead and type in templates and under Vertani 1, and you should be able to find a short video on how to make those. All right, but go ahead and hit OK. Make sure part is selected. There were 3 primary file types, so note that you might not have noted there. There's parts, assemblies, and drawings. The first 4 weeks we cover are just part files. The 5th week we look at assemblies, and then the 6th week we look at drawings, which is the 2D element, where we could actually create a 2-dimensional drawing. But let's go ahead and hover over on the left here. This is what's called the Feature Manager Design Tree. And I might just call it the feature tree or the tree for short. On it, you could see the part name is there. And when you start a new part, it starts off part 1, part 2, part 3, and you get to rename them if you like. There's some additional elements on here. You'll see materials. If you right click on that, you could go and you'll find that there's some basic materials to select from, or you could go to edit material. Now, the benefit to this is that when you do pick a material, like if we were to look at 1023 carbon steel, and you could see here, if we set it to megapascals, and that's what I choose to use. I know we're using the English system here, but I do prefer the SI system for analysis. And as you can see here, we could find the tensile strength, the yield strength, and so on and so forth. This information actually plugs right in, and later on, you could actually find out how much this weighs, so you could order material. You could also use it for the finite element analysis, which we look at in the 3rd class. Anyways, let's go ahead and scroll down. You'll see there's a library here. You could actually customize this library as well. Go to aluminum alloys, and we're just going to go with 1060, which is a very soft aluminum. And you can see here the yield strength is only 27. So anyhow, but there are options. Notice it actually picks up the appearance. SolidWorks is programmed in. The appearance is in advance, so it's going to kind of look like the material you select, which is really cool. You could override it, though. It's not hard. Also, cross-hatching is already set up, and financial impact, like in US dollars, how many kilograms per kilogram, how much is that value? So there's a lot of really neat things. You're going to have to keep adjusting that, though, I would think. But go ahead and just hit apply and close. And it's my understanding if you just hit the X, it will apply it as well. So anyhow, now our material is set up, and you have these planes. The planes, front, top, and right, are paper that you're going to sketch on, and they all intersect each other, and yours may not be on. There's a little point there. That's my origin and space. It doesn't move typically, but basically we're going to use it as our anchor point, and that's a good way of modeling, actually. And here, as I click on the origin, you see it highlights right there. And as you hover over this, it highlights too. This can be a factor if you have an ARC graphics card. currently there's some issues, and I'm going to go into the options menu and show you how to turn that off so it's not so slow if you have an ARC graphics processor. But anything else just works fine. I'm not saying the ARC processor is bad, it's actually excellent, but you probably prefer a professional version of it. Okay, so anyways, so we're going to go ahead and select the front plane. And when you click on the front plane, you can see over here, you could change the name of the text, or you could go right to this little icon on the quick launch. Notice I clicked on it a couple times because I was fiddling around with it. But that's the quick launch toolbar, and that's for high efficiency. Otherwise, if you move your pointer, it evaporates, but easy enough to fix. You just go up to Sketch and you'll see Sketch here. Now, if you were to hit the little arrow under Sketch, you'll see that there's Sketch, 3D Sketch, 3D Sketch, and Plane. 3D Sketches, we get into an exercise 7. So you could type in E7 SolidWorks and you'll see what we do with it if that's what interests you. But that's really great for piping, for tubing, things like that, like if you're making an exhaust system for a car or bicycle handlebars. It's not practical for what we're going to do today. So we're just going to stay with Sketch, which is essentially a 2D sketch. So now you have all these tools at your disposal. You have the lines and rectangles and things. Line tool is very easy to use. We'll see that in the lab. But if you hit the little arrow to the right of the rectangle, that's what we're going to start with today because it's super easy. And you'll see corner rectangles, center rectangles. We will use center rectangle in a few minutes. So if you hang on, you'll see how that's used. That's a great tool. But corner rectangle, we'll start with that. When you click on it, you'll see you still have those same options over here. You could flip-flop. There's parameters that you could type in. I don't recommend it. AutoCAD users or of other systems typically like to plug it in. The thing that you have to remember is that it doesn't necessarily lock it into that dimension. Someone could come in and move it, or you might accidentally move it, and it could change the whole profile of your part. So be careful of using that. I recommend steering clear of it right now until you're a bit more advanced. But move your pointer over your origin. You'll see a little orange dot that appears. And go ahead, and when you get that orange dot, go ahead and click. Now, when I say click, I'm referring to the left mouse button. Left mouse button, we're going to use 90% of the time. The right mouse button, we use maybe a little less than 10%, of course. And then the middle mouse button we'll use for other things as well. But when selecting, we use the left mouse button, and I just refer to it as click. If I'm going to have another mouse button that I'm going to suggest, I'm going to say right mouse button, right mouse button. I'll say it twice just so it clicks and you know which button I'm referring to. Okay, so move your pointer to the upper right and you'll see X and Y values appear, and currently we're in metric. And that's because this is set up, and you can see millimeters down below here, so mm, but that's okay. SolidWorks is very forgiving when it comes to those. So let's just click and have a rectangle that looks like that. That's good. Don't worry too much about the dimensions because those were just to get you close. Now go to Smart Dimension, and if you hover over this edge here, when the whole edge turns orange, that's when I want you to click. Don't do this though. Don't click on the points. There are midpoints, there's endpoints and things like that. We do use those from time to time, but I just prefer one click. It's just more efficient. So click on the line itself. Stay away from the points. And now move your pointer to the left and you'll see you get a dimension. And those of you who are not familiar with dimensioning, try and center the dimension. You want to make it look easy to read. That's the whole concept of dimensions. It's like if you put it over here and it's overlapped by lines, it's difficult to ascertain what that is. So make sure you click and just drop into the center. Now, I told you this is supposed to be in inches, and you can see we're in metric, and that's fine. Go ahead and type in 5, and then type in IN for inches, or you could use the quotes. You could click on that too and add that. Now watch this. When you hit you could hit the green check mark. The red is if you want to cancel out. But hit the green check mark for right now, and it will update. And it gives you the equivalent to metric, because that's what we're currently in. So 127. Now, if you are in inches, just leave it in inches, and because I'm going to show you the options menu in just a minute here. But now hover over this line down here and click. Move it to the center down below and click. Again, stay away from points. Click. And now this needs to be 3. And does anyone remember, if we wanted it in inches, what are the 2 things we could do? There's actually more than just 2 things you could do, but I'm just showing you 2 for right now. Okay, you could type in IN, or I said you could type in the quote. Okay, so either one is fine. and you could hit enter or the green check. It will give you the metric equivalent. Now hit your F as in Frank, the F key, and it will zoom to fit automatically. That's a fast key. So just keep that in the back of your mind. It makes you look very efficient if you ever interview when you know the fast keys, even though a lot of us don't use them all the time. Anyhow, so now that we have that, the universal key to get out of anything, we want to get out of the dimension tool or almost anything, is the escape key. So if you hit escape one time, sometimes two times just to be on the safe side in case you didn't hit it right, but you'll see it escape out of the dimension tool. So we're no longer dimensioning. We can see our dimensions here, but we want to change it. And now go to the lower right corner here, and mine says custom. Yours might say MMGS, and guess what that stands for? Millimeters, grams second. Hit the little arrow to the right of that, and we want to be an inch pound second. So go ahead and select IPS. Now what it does, it kicks you out and your dimensions disappear. Don't panic, it's behind there. Notice the color changed. It's actually changed to a light gray or dark, kind of a gray. To re-enter that mode of editing, you could double click. So hover your pointer over here and you're just going to double click and it will re-enter. And look at that. It actually has updated the dimensions 5x3. Now, if you're wondering how, remember I said hit the F key to center it. I was also using a little trick there, which it's using the scroll wheel to scroll in and out to zoom. You could zoom up the corners by focusing your pointer wherever you want it to zoom and just scroll the wheel on your mouse. Okay, and again, just hit the F key to fit it. Now, one other thing, if we're in the United States, like I said here, this should be the American National Standard. I mean, we could use the ISO, which is the international standard. That's great too. But what if I want to show you that? This is where I take you into the options menu. Now, you could have accessed under here, IPS, there's edit document units. That will bring you to the options menu. That's one way. The other way is just the gear at the top. So click on this gear, which is options. Now, this is what I've heard referred to as the heart of SolidWorks. And I really like that because it has almost everything, almost, not everything, but most everything that you'd want to change. And it's divided into two categories. There's a system options. These are global settings. Whatever you change in system options will update every time when you start up SolidWorks. It's in there already. Now there's document properties, which are just effective for the current document that you have open or that you're accessing. Okay, and currently the only one we have open is this one. So you'll see right here, the drafting standard, ISO. If you hit the little arrow to the right of it, you'll see all the different standards that are there. We're just looking for the ANSI. So go ahead and select American National Standard. And those of you in my class, I don't really care if you use ISO or ANSI. I'm just showing you this. So don't panic if you can't remember to do this. I don't grade on what standard you use, but it is good to use the right units for sure. All right, so you can see we had ANSI. Now another area you might want to go, if you go to units and the length, currently it's only set to 2 decimal places, and it does kind of round it up, and sometimes that's annoying. Remember, the lower the precision, basically these trailing zeros, the cheaper the part can be versus when you start adding zeros to this part, essentially making it higher tolerance. Higher tolerances cost more to make, but that is how we make quality products. So it's up to you, but let's click on this. And let's say we want to go to 3 decimal places. So 0.123. Okay, that's going to say, oh, it's overridden the ANSI standard. That's okay. All right, so now one other area, those of you, I mentioned the ARC graphics, and the reason I mentioned this because I have a couple ARC graphics cards. I love them, they're great. But with SolidWorks, if you don't have the Pro version, I do have a Pro version, it works great. But if you don't have a professional graphics card, sometimes you get some weird things. So if you go to, let's see here, Feature Manager, if it's really slow when working with it, just go over here, Dynamic Highlight, turn that off. And that seems to really help make it go a lot faster. So just be aware, leave it on if you have any other type of graphics card. If you have a NVIDIA graphics card, all of those seem to work really well with SolidWorks. AMDs work really well too. Anyway, so I went ahead and I applied that. You could see it exited us out of that sketch again. You could either double click. If you're not able to double click on it to access it, and I've seen this happen, and I don't know if it's the mouse or the user, but you could also right click, And right there is Edit Sketch. You can also right-click in the feature tree on the sketch that's listed there and click on Edit Sketch. Now, this is where I'm going to talk a little bit about the feature manager design tree. That is going to keep a history of everything you do chronologically. So the very first thing is going to stay at the top as always. All right. Okay, so now if you, let's click on that and go to Edit Sketch. Now you may not be getting those little arrows. That's more advanced. We're going to talk about that in a different lesson. Okay, anyway, so you can see you can move these dimensions. You can also double click on them and change them. Actually, this doesn't need to be out there that far. Let me squeeze it in. All right, so if I wanted to, I could use this little bar. Click on that and adjust it. Okay, if you hit cancel, it will update without it. So without the changes. So for conceptualization purposes, it's very nice. Okay, let's go ahead and get this thing done. Go to features. Now, features are the three-dimensional tools that bring you into the 3D world. Notice that a lot of them are inactive. It's the object action paradigm where basically it's not going to give you tools you can't use yet, but it does give us a couple. And one of them is extrude, and that's what we want. So click on Extrude Boss Base. And you can see it's starting to give us a preview of a yellow part. Look at this little handle. Click on it, and you get a ruler, and you can drag it forward. In this case, we want a 1/2 inch, and it might be a little challenging to get there. So sometimes when it comes to 2 or 3 decimal places, it might be easier on the left. Just type in the value. In this case, let's type in 0.5. If you're still in metric, remember you can type 0.5 IN. Okay, or else you go here to units and select from the list. Okay, so that's the third way now you've seen. Go ahead and hit the green check. Now, you see that blue geometry left over? It's just residuals from what we just extruded. To get rid of it, just either hit escape on your keyboard or click somewhere. It's just kind of garbage left over. Just needs to be refreshed. Okay, so now that we have that, let's see how we could rotate this. Now, on your keyboard, your arrow keys, hover, go ahead and click on your left arrow key. You'll rotate left, your right arrow key, right, in 15-degree increments, up and down. All right. Now, if you hold Control and hit the left arrow key, that's pan, left and right, up and down. If you hold Shift, it'll rotate 90-degree increments. And I don't expect anyone to remember this stuff, but just you could always come back to this video if you want. All right, Alt rotates clockwise and counterclockwise. And that's with the arrow keys. All right, so there you can see there's a number of tools. Now, also, your right mouse button, as you hover over here, hold down the right mouse button and move to your right, and that will bring you to right view. Hold down your mouse button, your right mouse button, and move to the left or top, and it will orient you to those. So look at all these different tools just for orientation. Now here's the one that's most important, the space bar. If you can remember this one, you're going to be in good shape, because those others, you don't really need them, but they're really nice to have. Hit your space bar. And the space bar brings this up. And let me squeeze this down a little bit. This probably looks more like what you have. And this is the orientation box. And notice there's a cube here. If it's not there, click on this. This is the view selector. Turning it off just gets rid of it. But you could also tack this in. And you could go over here to isometric, dimetric, trimetric. I'm going to go to isometric quite a bit in here, so retain this. Notice if you hover over it too, it tells you the fast key. It's not telling me the fast key. I'll find out what it is. It'll show up in just a second here. But anyway, here's the front, right, back, and there's the control keys. See how it tells you which one, like Control 3 brings you to the left side. You could also do this. You could have multiple 4 viewports. Some of you might come from like Rhino, or where that's very useful, where it's like makes life really easy. I used Rhino quite a bit. I have videos on it. In SolidWorks, it's not really necessary. For Rhino, though, it's massive help. So you could go back here to single view. I wouldn't use that. I mean, unless you really want to. Some people like it. Okay, so anyways, if you ever go into a shop and you see someone has this floating around on their desktop, it's a good possibility that they've been using SolidWorks for well over 20 years, because in the 90s, this is all we had to use, but they've added all these new functions. So anyhow, let's just make sure you're in isometric. There is one more one. This is normal to. It enables you to select a face and go normal to it. This isn't a good example, but anyways, just know that one's really handy too. Go ahead and hit, you could hit close. You don't have to tack it in. All right. So now that we've seen how to do that, here's another way to rotate. And I promise it's probably the last one. On your mouse, okay, there's a wheel. Now we've seen the wheel zooms in and out, but if you push it down like it's a button, hold it, move your mouse left, right, up, and down. That's dynamic rotation. So really easy. The wheel, push it down like it's a button. Don't scroll it. Scroll it. I mean, you could scroll it. It's zoom, but for rotation, just the middle wheel. That's all. Okay, and if you have a 3-button mouse, that's what it does instead of a wheel, but most mice have a wheel, I suppose, these days. Okay, one other thing you might notice is yours might not look like mine, like, hey, where's your shadow, or where are all these things? That is dependent upon what I mentioned earlier. If you have a professional graphics card, hit the little arrow next to this television set and you'll see real view graphics. Some of you might not have access to that. And if you don't, it's simply because your graphics card doesn't support the professional settings in SolidWorks. Okay, certain graphics cards do. Usually they'll have Pro on them. So for example, the Arc Pro will have it. The Radeon Pro versions will have it. Like I have a Radeon Pro in here. It's a 6400 and it's a great card, W6400. Great card, not too expensive, fits in almost any case. Anyways, then there's the NVIDIAs. Now, the NVIDIAs kind of switched over. A lot of their graphics cards, even their gaming graphics card, now support the real view, which is really cool. Like even their 1030, which is a really like a card from 2017. I was shocked it supports it. Not all of them do, but a lot of them do. But typically it's their Quadros or their T series, so T1000, T600, or their A series, A1000, 2000. Those will do it in higher ups. Then they get really expensive, by the way. All right, so anyways, and there is a hack out there. If you go on to YouTube, type in Real View, SolidWorks Real View, and you'll see that there are several videos, and each graphics card is a little different. There's like really, it seems like there's 3 ways you could do it through there. I don't recommend it because unless you're a pretty savvy computer user, because you're fiddling with your registry settings, and if you screw it up, it could cause some trouble. So I don't recommend it, but you'll see there's a ton of videos out there on how to do it so you get this appearance. And you'll see some advantages to Real View in a second. Anyway, sorry. Okay, now also there's Apply Scene. You have plain white, you have rooftop, factory background. There's a lot of different ones here. If you don't have Real View, this is what your part probably looks like, okay, which doesn't have shadows and things. So anyway, I like turning it on. I like it. Some people don't like it. All right, there's also Zoom to Fit here. And there's Zoom to Area, which clicks, and you can zoom up to that, hit Zoom to Fit again. There's Previous View, which brings you back to the last view. There's Section View. If you click on this, now be careful with this one, drag it forward a little bit, grab the rings and rotate them, and you could section through, and over here there's even more settings, section through and hit the green check, and you see, oh wow, look at that. You could even work in this mode, but just beware you can't see the whole part. But anyhow, to turn off, you just click on Section View again. And then this, look at that. That's just like what we did earlier. Does anyone remember how to bring that up with the fast key? It was the one I told you to remember. Spacebar. Spacebar does that. Okay, but it's right there too. Now here you have some additional settings. You have shaded, so it takes away the edges. Here is hidden lines removed, which is just what you see there. There's hidden lines, so you can actually see the hidden lines as dashed. And then there's wireframe, okay, which is kind of hard to ascertain what you're looking at for most people these days, even though we used to model in wireframe in the 1990s. So in 1980s too, because computers weren't very powerful back then, and wireframe could be handled much easier. Okay, so anyhow, we have this now. Let's go ahead and we're going to add to this. So select this face and go to Sketch. And again, go to corner rectangle, go to the lower left corner when you get the orange dot, click, move your pointer to the right. Now notice if you go too far, you'll find a midpoint. We don't want that. You want to be below midpoint. Y should be equal to like 1.5-ish. That's what we're aiming for. Pretty close to it. Okay, so click, you got your geometry, go to Smart Dimension, hover your pointer over the line over here and click and move it to the right. Now look at that, our dimensions are updated. This is the American National Standard. If you still have it set to ISO, the International Standard, where it's actually rotated 90 degrees, that's fine, I don't care. It's just preference in this case here. Some companies will care, but I don't. All right, so anyways, here we're going to type in 1.5, hit enter or the green check. And now we could go to features and extrude boss base. It throws us into an isometric view automatically. And it remembers our 0.5 setting. Hit the green check. And remember that set scribble left over. Anyone remember how to get rid of that? Escape or click somewhere on the screen. It'll disappear. Okay, so now that we have that, we're going to now learn how to cut a hole. We're going to cut a hole right about here. Let's select that face. And go over here to sketch. Again, use the quick launch. Just makes things easy. Click. Take your pointer, get over the circle tool. If you hit the little arrow to the right circle, there's only one other option, perimeter circle, which I never use in this class, but just go to circle. And now move your pointer to the upper left area here, similar to where I have mine. Click, move your geometry out. It always gives you a radius from here. So a radius, remember, is half of a diameter. So we're looking for a 0.75 diameter. So 0.33-ish, like that, looks pretty good. And now let's go to Smart Dimension. Click on the outside of the circle, move it up here, click and make that 0.75. Now, to center the circle, because remember, if you were going to drill this, you would use a ruler to figure out how to locate that. So we're going to put those dimensions in so someone can do that. So select the center point and select this left edge. Now move your pointer up, center to the dimension, get it off the edge of the part, click. It's going to be 1, enter. Notice I don't type in 1.000. If you do that, be careful, because that's a what not to do when you're interviewing for a job, because it makes you look like you're not that well versed in the software. And don't mean to hurt your feelings or anything, because I used to do it. We're all guilty of it. I even still do it sometimes when I'm lazy. But let's look at that again. Click on that top edge that I just did when it turns orange. Click on the center point. You could click on the circle tool. It'll automatically go to the center point. Now move your pointer to the left, center the dimension, click. And this is what not to do. Like, what not to do is click here, hit backspace, and then type 1.000. Okay, that makes you look, if you go in an interview, they might ask you to sit down and prove what you know with SolidWorks. What do you think looks better, that or what I did where, let's do that again. I'm going to click on this and delete it. So you could delete dimensions by clicking on them, hit delete on the keyboard. And I'm only showing this to you just so those of you who want to interview, you're going to look better. So again, I'm going to try putting this in. I'm going to click. Now watch this. While it's all highlighted, there's no need to backspace, no need to delete it. Just hit 1. And if you know there's just trailing zeros after it, we'll leave it at 1 and hit enter. It'll automatically put those in for you. Look at how much more efficient that looks over what I just showed you. Just remember, if you interview, that's what's going to make you look really professional. Okay. All right. So now we could go to features, extrude cut. And now we could have it cut through earlier. It's interesting. It's decided to go with through all here, which earlier was set to blind, which you might see that on earlier versions. It's almost like there's an AI in here in this latest version. I never saw that happening before. But anyway, blind would be 0.5. And there's something called design intent, which I want to speak about just briefly. Don't want you to think too much about it, but I want to plant a seed. So later on, when you become more fluid with this or fluent, you're going to be exceptional at it. Design intent is your plan and how you want something to operate and maybe update in the future if someone needs to edit it, because in design, change always occurs. Like in this case, we have a 1/2 inch thick black, that might need to get thicker, might break. And so it's like someone would say, make it 3/4 of an inch or an inch. Well, if you do that and you have this cut hole in here at 0.5, you're going to have to remember to go back and change the depth of the hole to match the feature. Design intent is the thought like, hey, how can I make that easier for the next person so they don't have to remember that? Here's how. Click on the little arrow. And this is just one simple example. There's lots of examples. Don't think about it too hard with this one, but as you get more used to it, it kind of comes naturally. Okay, so there's other options here. We could say through all. That will ensure no matter what thickness that changes to, it'll always be through, because let's say a bolt has to go through there. Does it make sense? Hopefully so. Anyways, hit the green check. There it is. Click off of it, and you can now see we have our hole. Okay, now at this point, we just have to save off an image for those of you who are my students to put into the system. And look at this, even asking us to save. I'm going to cancel that right now. But here's what I want you to do. By the way, for those of you who are my students, this is as far as this lesson goes, but I'm going to add value to it to where if you want to learn about how to change the colors, how to put in those fillets and those chamfers, which you will learn a little bit later, keep tuned. And it's only 5 to 10 minutes extra, but it's going to make you shine, okay, if you can do this. Anyways, those of you who just want to finish, here's how. Right now, just go to File and go to Save As. And instead of SolidWorks Part, okay, save it as an Adobe portable document format. And go ahead and you're going to label this E1 for exercise 1, and go ahead and hit save. And that's it. All right. And then you could submit that in the digital folder. So under assignments, and you'll find exercise 1 or E1, submit it in there, and then I could grade it. Okay. Those of you taking my class, just be aware if you're missing something, these parts, I actually send them back to you. You are able to fix them if you miss some things. So just be aware of that. Okay, now those of you who are staying tuned, let me show you some additional tricks. Okay, so first of all, I'm going to put some of those fillets in. Now, fillet is a radius. It's a round, like if you're going to file an edge. Click on fillet, super easy. And set it to 1. So that's 1 inch. So I'm going to put the decimal place after it. Select this edge. Now, you may not see a preview like that. Make sure over here on the left, that full preview right here is turned on. Okay, then you'll see it. Go ahead and select this edge. Now, be careful, don't select the face. Now, how do I know I'm selecting a face versus an edge? Look at here. As I'm hovering over this face, I get a square to the right of my pointer. That's an indication it's the whole face. The topology of that face are the edges. If you want to put fillets on everything, then you can select a face. I don't recommend it here because it won't be able to fit at 1 inch. It's too small. Anyways, we want an edge. So what does an edge look like? An edge looks like this when you hover over. Actually, let me click. As I hover over this edge, it turns orange. And to the right of my pointer, I get a vertical line. So that's how you know if you're on a face or an edge. And SolidWorks does let you fillet a whole face. We do it a couple times in this class. It is very efficient. It's a nice tool. But remember, most of the time I'm going to say select an edge. So there you go. So click on that edge. And it's just like you're filing that edge. Go ahead and hit the green check, and that will apply it. There's your fillets. Look at how much better that part looks. This is portfolio magic. So those of you who are looking to get a job or a career in this, keep up with this and follow the next 5 minutes of the video, and you're going to have a wonderful little piece to show off. Okay, now we're going to look at chamfer. Now, chamfer is underneath the little arrow underneath fillet. And so go to chamfer. And over here, there's different types of chamfers. We're going to stick with this, 0.125 and by 45 degrees, okay? And that's going to ensure on a 90-degree angle that it's going to be 45. So even if you want 0.125 by 0.125 for the depths of both. But go ahead and select this edge. Now notice it carries around. That's because of tangent propagation is turned on. If yours is turned off, it won't go all the way around. Okay, notice it only follows where the fillets are because that's tangency between a radius and a straight edge. Over here, it's no longer tangent and stops, and over here, it's no longer tangent. So that's why it ends. Let's go ahead and select this edge too, right here. Okay, and if you accidentally get a face like this, look at how it did everything. Here's how to deselect it. Just click on it again, and it turns it off. Okay, so that's one way. You could also go over here in this blue box, and you could right-click, and there's delete or clear selection. We don't want to do either one of those because this is correct. But go ahead and hit the green check, and now we have chamfers on there. Now, let's rotate this. Does anyone remember how to rotate? The arrow keys. You can rotate with those, or better yet, the wheel. Hold the wheel down and rotate. And tinker with this. Spend a little time on it. Rotate, because rotation is so important and vital to 3D modeling. So just be aware of that. Pause if you want, and then tinker with it and rotate a little bit. Okay, now we're going to shell this out to make it a thin-walled part. So go up here to shell and set it to 0.062 and select the faces you want to open up. So click on that face, because right now everything is being shelled inside there. It's currently thinking it's hollow. In fact, if you go to show preview, you can kind of see the outline of it. Okay, now you can select more faces. Go ahead and select this face and this face. Now remember, you could deselect them as well by just clicking on them again. But those are the 3 faces you want. Hit the green check and look at that. You now have a fairly complex part that you just threw together in a matter of minutes. So that's what I was saying. When I do this added value stuff, it's really going to help sharpen your skills. It's going to make you like a pro much quicker than if you just do the basics. Okay, now another thing to make it look even better. Click over here on the little TV set to the right of it and go to perspective. Perspective adds a vanishing point. Like, you know how when you look the backside of a room, it gets smaller the further away it is? That's what it's doing here. And that makes it look more realistic. Step 1. Step 2, let's add some different materials to it. So go ahead and select the model. Now it's set to aluminum, but it's a kind of a satin finish. Okay, and it's not really shiny. Let's say we want to make that shiny. Click on this face. Now find the beach ball with the pencil and hit the little arrow to the right of it. And you can see you could paint an individual face. That's the blue face currently. The entire extrude, which would be, the other features would be exempt from that. The entire body, because you could have multiple bodies inside SolidWorks, or the entire part. Or you could just choose remove all. Okay, but here, go over here to the silver ball and part. Now yours probably says part 1. That's fine, because I already had part 1 earlier. Now looking on the left, you have this library. Now over here on the left, I'm sorry, this left, you have colors. If you just want basic color changes, that's fine. Over here is the cool stuff. Click on aluminum, and you'll see down here, you could scroll. There's polished aluminum. Click on it, and look at it, brightened it up a little bit. Hit the green check. Now, let's paint the chamfers. Click on this chamfer right here. Go to the beach ball, hit the little arrow, and this, you could do the individual face, which is kind of boring, or do the whole chamfer. So that's the whole chamfer feature. Click on that. And over on the right, hit the little arrow to the left of metal to bring it up. But go to painted and hit the little arrow down, go to car, and actually you can pick whatever you like. I don't really care what you do. Have fun with it. Experiment. Those of you who are artistic, have fun. Anyway, I'm going to go with gloss blue. Hit the green check. Look at that. Now the chamfers are blue. Now let's say we wanted to copy that color and you didn't want to have to find it in here again. Click on that surface of the blue. Go to the, right here, the dual beach balls. Go to copy appearance. Now select the surface. Now remember, the surface indicates the little square. Click on that surface and go to paste, which is the clipboard. Now, don't be too quick here. When you click, you have some options to hover over these. You could have the whole body or just the face. Go ahead and select just the face. And there you go. All right, so look at that. Our part looks a whole heck of a lot cooler. Now, at this point, if you want to save it, you could go to save and go ahead and label that E1 and just hit save. Save it where you know you're going to be able to find it. Let me call it E1E because I already saved one. All right, now you want to make a PDF file. You could go to File and Save As. Now there's two ways to make a PDF. You could either go here and find Adobe PDF, okay, or you could go to the print. If you go to File, Print, and set it to Microsoft PDF and hit OK, and then save it that way. So there's several ways you could do it. Those of you taking the simulation class in the future, that might be the better option. You could print out the screen versus sometimes it doesn't save the analysis the way you would think. Okay, anyways, one last thing. Let's go to Evaluate, go to Mass Properties, and there we can see how much it weighs, 0.12, and that's with the 1060 alloy. If you change the material, that will update. So now we know how much it's going to cost. Well, not really. We basically know how much material at least. And that, there's one other thing. Some of you may or may not have this. You'll see SolidWorks Visualize. If you don't have SolidWorks Visualize, there's another option that might bring it up. If you go to Tools, Add-ins, and from here, not everybody has this now, you'll find SolidWorks Visualize. Check this box and check this box and hit OK. It should appear now as a tab. But if you don't have it, don't panic, don't worry, because you just don't have it then. Some schools get it, some don't. But you could go to Export Simple, and it brings up SolidWorks Visualize, which is a package that will allow you to photorealistically render this to where it looks real. Okay, and it's pretty neat. So those colors and things that you added carry over to it. So you could set it all up there and then bring it in here. And also you could edit those colors in here as well. And so here you can see what's going on. There it is, and it's rendering. You can see down here, there's 3,000 passes it's set to because I have it set up here to accurate. And you can see how it's moving through. If you have a very fast graphics card, it will fly through this incredibly fast. Like if you have one of those new GeForce 4090s, oh my gosh, it would have been done already. This is not a super fast graphics card. It's a professional graphics card, but it's not the greatest for that. And the longer we let it sit, the better it's going to look. And you could change appearances over here. You'll see you have the libraries. You could just drag and drop them onto the surfaces and things like that. You could even make a video. There's rotate, there's turntable, and you could have it make a video for you. Here's the output right here. So you could go to the render wizard and tell it like what type of image you want, if you want it high definition or 4K quality, and you could go through. I personally just like to do Windows Shift S, as in Sam, click and drag a fence to surround it. And down here, it's already put away in your pictures directory under snipping tools. So you already have an image much faster than setting that and waiting for it to render, because usually the screen and the preview looks pretty good. Those of you who have different graphics cards, you go to Tools and Options, and you could set that up to utilize those. So like right here, there's there's only two now. There used to be three. Anyways, there's 3D Stellar. Those of you who have an older version of SolidWorks, there's actually three, an NVIDIA one, but I think they discontinued that. But you could here set it to either one of those. So if you have a different graphics card, set it to 3D Stellar. If you have an AMD like I do, the Pro, it will actually utilize the GPU, and it can use the CPU as well. Apparently not on here from what I'm seeing, but sometimes it will tell you, like if I use 3D Stellar Physics, you could have it use the CPU and, in this case, CUDA cores. And those of you who know about CUDA cores from graphics cards, the thing is that the CUDA cores might only work from up to the 10 series or newer, might even be newer than that. Like maybe the 2000 series might be CUDA cores, and those might be still usable, because I've had older graphics cards that are like from 2016, 2015, and the CUDA cores were too old and the renderer didn't want to utilize it. So just be aware. Otherwise, it uses your CPU, which is fine. It's just a little slower, or it could be a lot slower. And the more cores you have on your CPU, it will utilize that too. So if you have one of these that has 36 or 128 cores, 38, I should say. It's going to operate really well. Okay, so that concludes this exercise. There's two labs, Lab 1 and Lab 1B. They're in the training guide. Those of you, if you want to find this information, you could go in and you could go to vertanu1.com, and here you can find the instructional manuals. Here's the SolidWorks Basics training guide, and that's for 2024. I still have to update it for 2025, but it's still the same. There's nothing really that's a huge change. You could probably do all the parts in here. The only thing that SolidWorks has done, they've added probably 200, 250 new features that are probably more on the advanced level. I think we saw a couple in there as is. Anyways, you could grab that there. If you need the part files, here's the part files for the other exercises. And the videos, you can find the video library in YouTube, and it goes through. There's exercise 2, exercise 3. And notice that some of these are from 2020. That's fine. I'm not seeing any major differences between the versions just yet. There are nice enhancements in 2025, but nothing that's going to probably adversely affect you from just using these videos. My goal is to update these as I need to. If I don't need to, I don't update them. But thanks for watching, and you have a great day.